So yeah, on the back here, just something kind of weird happens. You know, let's just solve it like we normally would and just see how this is going to play out. If I distribute the 3 here, that gives me 15x plus 6 equals 15x. And then without looking ahead, what would typically be the next step here?
Minus 6. Minus 6.
Minus the 15x on both sides.
Oh, yeah.
All right? That's part of that sort of combining like term steps, it's the sort of the second half of that. But what happens? Yeah, so what happens is all of your variables are going to cancel out here because 15x minus 15x is 0. So what we end up with is a statement 6 equals 0. Now, clearly, that is not true, right? Like that is a false, we would say that's a false statement.
So would you say that's undefined?
So when all of your variables cancel out, one of two things will happen. Okay, so listen carefully. Either, if your variables cancel out, one of the things that could happen is you end up with a false statement like this, like 6 equals 0 or 1 equals 2 or something that's definitely not true.
So it's not.
And, well, just hold on. The other thing that could happen is that you end up with a true statement. Maybe, like, I haven't written what the actual, like, answer is yet, but if you look at 14, when we distribute the 4, and we get 4 minus 4p equals negative 4p plus 4, and then I take the next logical step, which would be to add 4p to both sides, I end up with a statement, you know, these will cancel out, I get 4 equals 4. Right? Here's an example of all of the variables canceling out, and you end up with a true statement. So these are the two sort of special cases when you're solving these linear equations. It's like if all the variables are going to cancel out, then either you'll be left with a true statement or a false statement. And depending on whether or not the statement's true or false, will determine sort of how you answer it. Okay? If you get a false statement, like on 17, then you're going to say that there is no solution. And what that basically means is that there is no number on the number line that you could plug into x to make it true. It's just there's no answer, essentially. However, if you end up with a true statement, you end up with something called an identity, which means that this is a statement that will be true for all the numbers on the number line. Meaning it doesn't really matter what you plug into p here. You could test any number you want, and it'll work. Usually in these linear equations that we're solving, how many solutions are we typically getting? Yeah, just one, right? Like x equals some specific number. These two cases are special cases where you either end up with no answer or just like everything is an answer, right? Like there's no number on the number line that if I plug it into p here that it's not going to work. Everything will work. So if you get a true statement, the way you answer that is you say that there are infinitely many solutions. Okay, well, we're gonna finish this. I don't have time for that. All right, so just to sort of summarize this, because I know we're about to go here. And again, these problems on the bottom, I'll make sure they're worked out for you too on Schoology. So if all the variables cancel out, you're either going to be left with a true statement, like 2 equals 2 or something like that, or a false statement, you know, like 1 equals 2. That's a false statement. If it's true, you're going to say infinitely many solutions, or you might just abbreviate it IMS. We'll know what that means. Infinitely many solutions. Or if it's a false statement, you're going to say no solution.